In this video, we'll evaluate the integral of 1 over the square root of e to the x with respect to x using the substitution method. We have the integral of 1 over the square root of e to the x dx. Our goal is to find a substitution that makes evaluating this integral easier. Step 1. When should you use substitution? Look for a portion of the integrand whose derivative appears elsewhere in the integrand. Notice that e to the x is in the denominator of this integrand. Let u equal e to the x. If e to the x is expressed as u, then the integral simplifies to 1 over the square root of u, but we also need to change dx to do. So we differentiate u with respect to x. The derivative of e to the x with respect to x is still e to the x, or u. Therefore, do equals e to the x dx. Solving for dx gives us dx equals do divided by u, so we can substitute this into the integral. Step 3. Substitute u and dx back into the integral. This changes the integral into the integral of 1 over the square root of u multiplied by do divided by u. Step 4. Simplify this integral. Divide by u gives us 1 over u to the power of 3 halves. Integrating this term in terms of u is more straightforward. Step 5. Integrate using the power rule for integration. Add 1 to the exponent and divide by the new exponent. The power rule gives us u to the power of negative 1/2 divided by negative 1/2. Step 6. Let's simplify this. Dividing by negative 1/2 is the same as multiplying by negative 2. We get negative 2 times u to the power of negative 1/2 plus c. Step 7. Substitute back. Remember, u is defined as e to the x. Substituting u back in, we have negative 2 times e to the power of x to the negative 1/2 plus c, which simplifies to negative 2 times 1 over the square root of e to the x plus c. This is our final answer. And that's how you evaluate the integral using the substitution method. We found that the integral of 1 over the square root of e to the x dx is equal to negative 2 over the square root of e to the x plus the constant c.